And it allowed people to manage who had access to what resources. It could create a sort of a unified picture of security. It supported very large, diverse networks, and it was able to deal with some very complicated data. Now, they tested this with the supported configurations, but they didn't test with the size of supported configurations. And so, interesting thing happened. One of their customers decided that they were going to run a query, an automatic query every night that was going to go out and query all of the systems and make sure that what came back from that query corresponded to what was in the central workstations repository of here's the universal access picture across our network. Okay, so far so good. That makes sense. Client says or customer says to my client, hey, can we do that? And the client says, oh yeah, sure, that'll work just fine, no problem. Well, no, big problem, because they'd never tested anything like that in a realistic environment. And so what happened was it took 25 hours to run this query, which they wanted to run every night. And as you can imagine, a 25-hour duration is not a good duration for a job that needs to run every night. So this is an example of this unrealistic environmental testing kind of slapping people in the face and leading to an embarrassing situation with a customer. And I want to point out here, just because a lot of people forget this, if your systems deal with a large data set, remember that the data is part of the environment effectively. And so don't test in a realistic environment, but with small databases if your actual application is going to have potentially millions of records in the databases, and you only have a few thousand in your test environment, because again, that will be a way in which you'll be confronted later with unforeseen production failures, and people will be saying, well, why didn't you test that? Oh, I did test that. Well, yeah, you did test it, but not with data that was realistic. So as a counterexample to that, here's a successful story. We're testing a banking application recently and built a test environment that mimicked the production environment. And the differences were limited to a couple areas where the bandwidth was not as big as the production environment, but we had carefully looked at both through testing and modeling whether those differences would affect the results, and we were convinced that those differences were not in areas of the system that would actually would be becoming bottlenecks. So we were fairly confident that there were a number of constraints that we would run into first. So to the extent that there are going to be any differences between your actual production environments and your test environments, make sure that you analyze those and understand them. And you can deal with them if there's a limited number, but each one of them adds the risk that you're going to end up missing something. This slide shows you that environment in the banking system, and you can see here we're talking about the difference in between the systems and the production and the test environment, and being pretty well understood as to what the implications of that was, and we did not anticipate that was going to create unrealistic results, just because we had a faster connection here than was going to be in the real case. So we set up the environment. We ran loads into the system from the call center, coming in through the call center into the system there, and we ran the tested steps. So each step added under 20 users, and what you're looking for is what's sometimes called the knee in the curve, or the hockey stick. And if you've not heard that phrase before, I will show you a little bit later what that looks like. That's basically the place where you hit the nonlinearity in performance degradation, and the system really goes downhill fast. Okay, so lesson 2, real world loads. So yep, you got to have a performance test environment, load test environment, reliability test environment that looks like production, maybe with some minor differences. You got to have data in there that's realistic, but then you have to test with realistic transactions and loads. If what's happening to the system under test does not look like what's going to happen to the production servers, when I say what's happening, I'm talking about incoming events, incoming load mixes, then your results will be misleading. So obviously think about the normal everyday usage. You got so many users of this type and so many users of that type and so many users doing this and so many users doing that. You want to think about what the mix of users is. But also think about things that can happen, like if at every night at 2 a.m. or every morning at 2 a.m. a backup kicks off on a server, that's something that needs to be simulated. Seasonal type of events for those companies that are in, say, e-commerce or something, you'd expect that your December would be very different than your January. If you're in financial business, then there's quarterly ending periods and yearly ending periods, and those are going to be different from a load point of view. And of course, you want to plan for the future. So if you're experiencing growth in your company, then you don't want to just test for the level of load you've got today. You want to look down into the future to look at the technology roadmap. Say, when do we think we're going to upgrade our technology? And that's going to tell you how long that your current systems need to scale, and give you some target for what the load test ought to go to. Now, another thing I think is very useful here is, real-world loads, but also go beyond the real-world loads. So once you've established that you can test like the real world, start cranking it up and see what happens as the system starts to fail. And are the results acceptable or unacceptable? Okay, so example of unrepresentative loads, underloading during performance and reliability load testing and paying the price. So we were working on a project that involved a network of interactive voice response servers tied to a call center, and it's a fairly complex collection of technology there. And then the key piece was the interactive voice response, or IVR server, because if this thing wouldn't scale up to handle a lot of simultaneous customers, and I mean a lot, then the business case was going to collapse, the business case for the project. So the developers were creating a software that would run on the performance, or on the telephony cards, and they said, oh yeah, we'll do the performance testing of that, they said. And then I started poking around into what they were doing, myself and a couple of my associates on the project. And we find out that basically they're taking half of these telephony cards, and each of the telephony cards had 4 ports, and they're putting loopback cables into the half of these cards and plugging them into the other half of the cards. And they're running a load generator on the first half and the software under test on the second half. And I said,